Hello and welcome to last Friday. It's Thursday's edition of Cracking the Cryptic. I'm losing the days. And yeah, what have we got for you today? We have got this puzzle on the screen, which is called, somewhat dauntingly, Where Are the Cage Totals by Mr. Menace. And this gave one of our testers the most troubling time. But she has passed it on to me saying that this is a fabulous Sudoku, just very difficult. So I am looking forward to giving it a go. And I've seen the rule set, and the rule set is just, it's fantastic. It's the most fantastically conceived idea, and that this could be made into a Sudoku is something quite exciting to me. I am looking forward to giving this a go. I want to mention something first, and that's about our Discord server, where, I mean, they have had some extraordinary news. They've just reached the milestone of 2,000 puzzles in their archive. That's 2,000 puzzles that have been created by members of the Discord server. This is a picture by Shy, who's often over on the Discord server, one of the world's great constructors, because basically to celebrate them reaching the 2,000 puzzle milestone, several of them have got together and created enormous puzzles in some popular puzzle types in order to sort of commemorate the occasion. These puzzles are enormous. They are 10 by 200 in terms of size. So if you think about a Sudoku being 9 by 9, you can imagine that a 10 by 200 puzzle is somewhat large. Too large, I think, for us to ever be able to showcase one in any reasonable way on the channel, but I certainly do recommend you have a go at these if you have some spare time. They will be marvellous, and I will put a link under this video to that puzzle pack so you can have a go. If you're not a member of the Discord server, you'll have to join Discord first, by the way. The puzzle, you can't just link to the Discord server without being a member of the Discord server. But being a member of the Discord server is it's as easy as pie. You literally just have to click on a link. There is no money to pay, nothing. You just become a member of one of the great puzzling communities on Earth. Well, in fact, the great puzzling community on Earth. I think we can say that without fear of contradiction. So that's something I definitely recommend. I also, of course, recommend our own Patreon site. Mark has just released, he did this a bit late yesterday, so apologies, it was a bit later up than my video suggested, but his battle with the Times Monthly Club Special crossword is now up and running. That video is over an hour long and is marvellous because you see Mark really struggle, and big thanks to all of you who support us over on Patreon, and do check out all of the extra content that we put over there. Now, what are the rules of Mr. Menace's puzzle? I will read them to you. Normal Sudoku rules apply. That's all good. Grey circles contain odd numbers. Grey squares contain even numbers. And digits in a killer cage, you can see the cages in the grid, may not repeat. The digits in the cage sum to the cage total, and the digits of the cage total indicate how many odd and even digits there are in the cage, in no particular order. Now this is quite extraordinary. So if you had a cage, I suppose it would have, if you had a cage that had a 24 sum, we would know it would be a 6-cell cage, and it would have to have either 2 even digits and 4 odd digits, or 2 odd digits and 4 even digits, etc. So the cage totals tell us the sort of the composition of the cage in terms of the parity. I mean, it's just a beautiful idea. I mean, this cross in the grid is clearly quite interesting to start with, and I think this has almost been put in as a joke. Because it's a 9-cell cage, given that digits can't repeat within a cage, we know it must contain all of the digits from 1 to 9. We know, because of the secret, that all of the digits 1 to 9 add up to 45. And think about 45 in terms of this parity argument. Well, the digits 1 to 9 consist of 5 odd digits and 4 even digits. So 45 is a beautiful number to include in this puzzle, even though it's sort of, it doesn't have 45 written in the corner. It's still there, and it's still resplendent. So do have a go. The way to play, as usual, is to click the link under the video. Now I get to play. Let's get cracking and Do you know what I'm tempted to do first? And this won't surprise anybody, and that is to switch to colouring, because this is clearly going to be a colouring puzzle in terms of odd and even digits. And I like to use, I think it's orange, isn't it? It's orange for odd, because they begin with O, and blue for even, if I remember rightly. So I'm going to do that to start with. I know it's a bit pedantic, but let's do that. So those will become blue, these will become orange, and now, of course, the puzzle will become much clearer. Or will it? How many's that one got? 1, 2, 3, 4, 5, 6, 7, 8. So that's an enormously large cage. Yeah, I think. Yes, I think. I don't know. I can't write in anything about this cage, but I do know this cage is missing a 1. How do I know that? Well, if it's got 8 digits in it, we know its cage total must sum up to 8. So it's either going to have to be made up of 1 7, 2 6, 3 5, or 2 or double 4. Now, however we think about the numbers, let's look at 2 and 6, for example. Is it possible that an 8-cell cage adds up to 62? No, that's not possible, because even a 9-cell cage only adds up to 45. 26 is impossible for an 8-cell cage, and we know that from the secret, because a 9-cell cage adds to 45, so that would imply the missing digit from this cage was a 19. Well, that's clearly nonsense. And 35 doesn't work either for a 3 and 5 pairing, because the other missing digit would have to be a 10. So we need something that sums up to 8, but also gives a cage total that's at least equal to 36. So it's got to be 44. That's the only thing that will work. And therefore, we know the missing digit is a 1 because of the secret. So that means there's a 1 in one of those 2 squares, I suppose, because in row 2 we can't put a 1 in the 44 cage. I don't have a very good way of labelling this as a 44 cage either, so I think I'll just have to remember that. Now, what do we do now? We've got another big cage down here. 1, 2, 3, 4, 5, 6, 7. So this time it's not as easy to see, at least not for me, what this is made up of. So it's not, I mean, it's clearly these aren't adding to 16 or 61. 25, no, okay, 25 isn't possible, because although 2 plus 5 equals 7, and there are 7 digits in the cage, the missing 2 digits, the 2 digits that are not in a 7-cell cage, would have to add up to 20 because of the secret. That's not possible. The maximum 2 digits can add up to, if they're different in a Sudoku, is 17 with 8 and 9. So what does that mean? So 2, 5, 52 is nonsense. So it must be 43. No, it's not 43, because 43 would require the 2 missing digits to add up to 2, and they would have to both be 1, and that's nonsense. So this cage, even though we know nothing really about it, we know it sums to 34. It contains 3 of one parity and 4 of the other. Don't know what to do with that. If I put 34 in the corner, will that work? No, I don't want to do that. I want to do that. Maybe that will remind me that adds up to 34. It also doubles the number of pencil marks I've managed to put in the grid, so that's good. Sorry. Look, I can use the geometry of the 45 cage. Sorry, I should have done this instantly. I only just spotted it. Look, these 4 squares, whatever's in that square, has to appear in the 45 cage somewhere, but it can't go in these yellow squares because they're in the same box as this square. So these squares that are sticking out of box 5 must all be whatever is in these corner squares of box 5, and therefore they are all orange. Good Lord. Now, I'm not sure what that means. It's almost Fistamafel ring-like, isn't it, in terms of these sort of patterns around the central box of the grid. In fact, that might not be such a silly thought. How many? 1, 2, right, that is it. Right, okay, lovely. Absolutely gorgeous. Wow. Right. Well, now I can make all of these squares blue. And I fully appreciate, if you're new to the channel, you will think what I've just done there is madness or magic or something. But it is logical. And how have I managed to just fill in all of these squares in blue? Well, it's because I know that there are 2 blues in that 2x2, 2 blues in that 2x2, 2 blues in that 2x2, and 2 blues in that 2x2. That's 8 twos. 8 twos? 8 blues. 8 blues in the 2x2s in the corners of the grid. Now, I happen to know, because of the Fistamafel theorem, that this ring here, it's going to be really hard to show this. Have I got anything else? Well, I have an open tab on my computer. I have no idea what Sudoku this is. Let me just launch. I'm just going to tab to it. No, this is fine. This is yesterday's Sudoku. Okay, so let's look at this. Ignore the cages. I'm just going to talk about the Fistamafel ring. So the Fistamafel ring tells us that these squares here, let's make those purple, and this ring here, make that green, these are the same digits, the same 16 digits. So whatever digits you found were placed in the 16 purple squares in this grid would be the exact same 16 digits you would find in the green ring. And you may say that cannot be true, and I appreciate your skepticism, but it is true, and I will demonstrate it with alacrity because I've had so much practice about showing this in videos over the years probably. Now, so the way to prove this, I'll do it by set, I think, because I like this version of the proof. What do the purple squares contain? They contain 4 sets of the digits 1 to 9 in the finished solution. We know that because each box will have to contain the digits 1 to 9 once each. So these purple squares are 4 sets of the digits 1 to 9. Now, if we just think about one of those 4 sets, let's just think about one of them and think about the effect of removing those 6 cells from that one set of the digits 1 to 9. If I was to remove these orange squares from that set, what digits would I be left with? Well, hopefully it's pretty clear that I would be left with these squares here, because all of these squares are different, obviously. So, you know, if these were the digits 1, 2, 3, 7, 8, and 9, for example, then in that set of the digits 1 to 9, I would be left with 4, 5, and 6, and they would also be those squares, because obviously those are the squares that are, or those are the digits in row 3 that are not those digits. So let's make those green. So now we know we've removed these squares, these digits here, from one of the sets of the digits 1 to 9, and we know that in that set of the digits 1 to 9 we're just left with the green ones. In other words, at this point the purple squares are 3 complete sets of the digits 1 to 9, because we've not touched 3 of the sets at all, and these 3 digits here, whatever they are. So these 3 digits will be appearing somewhere in the purple, we don't know where, along with 3 complete sets of the digits 1 to 9. Well, let's do the same. Now let's take another we're going to do the same in row 7, but we're going to take one of the sets of digits 1 to 9 of the purples that we haven't touched yet. So we know there are still 3 complete sets somewhere in these purple squares. Now from the second complete set, because we've already meddled about with the first one, we're going to remove those 6 digits. So in that set, once we remove those 6 digits, we'll just be left with whatever those 3 squares are. So now the purples consist of 2 sets of the digits 1 to 9 and whatever these green squares are. Now let's do the same with column 3. And this time though, I'm only going to remove those 4 digits there, those 4 different digits from the third complete set of the digits 1 to 9. Don't take them out. We'll only be left with those squares. And in the final set of digits 1 to 9, which we still haven't messed about with at all, I'm going to remove those 4 purple squares. Whatever was in those four digits there, I'm going to remove those from that set of the digits 1 to 9. And in that set, I'll just be left with those QED. So you can see now we have proved that these purple squares and the green squares have to contain identical digits. Now go back to this one. Let's go back to this one. How this is exactly, so once I knew that there are 8 even digits in the 2x2s, I've got to put 8 even digits in the Fist-and-Fell ring. But all I had at that point was odd digits. Boom, 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 boom. So the other 8 digits have got to be even. And we get here. And that feels like an enormous bit of progress. Well, okay, and the corollary of that, of course, is that all of these squares, therefore, must be odd. Let's do that. And does this show us the ways of the world? The answer is don't know. Don't know. So we've got lots of 3-cell cages. Oh. So we've got 3-cell I see. Oh, this is lovely. Right, okay. So let's look at that cage there. That cage contains 1 odd digit and 2 even digits. So we know the parity of the cage. It must be odd overall because 2 even digits will sum to an even digit. You add in the odd digit, you get an odd number. But we know that because of the rules of the puzzle, this is either a 12 cage because it has 2 of one parity and 1 of the other, or it's a 21 cage because it must use the digits 2 and 1 in the cage total. But it's odd, so this is a 21 cage. That cage adds up to 21, which is the set, and it's the same look as that one, same as that one, same as that one. All of these cages ringing the sort of going around here add up to 21. I'm not sure what we can do with that, but it's quite surprising to me that we can actually know it's true. One of the good things about this puzzle as well is that there's so little information. It feels quite doable to me at this point. This is famous last words, but you know, now I think we're going to either have to look here or here because I can't see for the life of me what else we're going to be able to do here. Is there anything? Do we know anything about a 21 cage that has 2 even digits? Oh, Yes, we do. Right, sorry, yes we do. Let's pause for a moment and think harder about a 21 cage. What would be the case if these two even digits were 4 and 6? Well, this square would have to be an 11. That does not work, so one of these squares is an 8. So we're going to get loads of 8s around the grid. There must be 8s in each of these cages. Oh, I forgot to put my phone on silent. That is going to be annoying if this is going to be a long video, so excuse me. I'm just going to silent it and put it over there. Now. So now I've got my first digit. That square. By the power of... No, not by the power of Grayskull. By the power of X-Wings, in a way. Look, each of these cages contains an 8. So you can see that the 8s... There must be an 8 in one of those two squares. Because otherwise we're going to run into a situation where 8s repeat in one of these rows or columns around the ring. I'm not explaining that very well, but for example, let's imagine neither of these were 8s. Well, then you would have to put an 8 in both of these squares, and you would have to put an 8 in both of those squares, because we know that each of these 3-cell cages contains an 8. So you're always going to end up with repeated 8s. So you know that in each of these positions here, there must be an 8 in one of them, and therefore these form X-Wings. If this is an 8, that will be an 8 in the finished solution. But if this is not an 8, this must be an 8, and that will be an 8 in the finished solution. And this works in the columns as well. So the only place you can therefore hide an 8 in the middle box is right in the middle of it. And I'm very pleased to put that into the grid. So now... Oh, I know what I should do. I can put 8s into these squares, can't I? There must be an 8 in each of those dominoes. Because I've got to put... Because there are 4 cages around the central ring that have to contain an 8, I've got to put 4 8s into the 2x2 boxes in the corners. And I can't do that by repeating 8s in a box. That will break the rules of Sudoku. So each one of these 2x2s has got to have an 8 in it. So there's... Now, do I know what these add up to? 21, 21, 42. I know this... Right, so we know each of these cages individually is either adding to 12 or to 21. It can't add up to 30 because you can't make 3 cells add up to 30. So it's not possible to think about sort of 3 even digits adding to 30 or 3 odd digits adding to 30. These either add up to 12 or to 21. Now, if both of these were 21, that would be 42 into those squares. These 3 squares would have to add up to 3. That's nonsense. The minimum we could make these add up to would be 6 with 1, 2 and 3. So can we have 12 and 21? If we had 12 and 21, that would be 33. These would add up to 12. One of them would be an 8. 8, 1, 3. Don't see why that's impossible. Oh, yes, I do. Yes, I do. 8, 1, 3 is impossible because those are even. And 1 and 3 last time I checked are odd digits. So you can't make this 8, 1, 3 because 2 of the squares need... these need to add up to an odd total. So this is not 21 and 21, and it's not 21 and 12, so it should hopefully be 12 and 12, which is 24, which means these 3 squares add up to 21, which means one of them is an 8, So the other two add up to 13 without using 8. So they're either 6 and 7 or 4 and 9. Which means 6 and 7 or 4 and 9, that square is a 7 or a 9. Those squares are 4, 6 or 8. These squares have to include a 1, 2 and a 3 in some order because we can't put those in there. And each one of these adds up to 12. Right, okay. I'm not actually sure that has advanced us very far. So where shall we look next? The ones have to be in... Oh yeah, the ones had to be in one of those squares, didn't they? So if this was a 1, there would be a 1 in one of these. Oh, you can't put a 1 there. This is a 21 cage. So yes, you can't make 2 squares add up to 20. So if there was a 1 here, there would be a 1 in one of those 2 squares. Do we know anything about that? Oh, it would, in fact, the 1 would have to go there. Because this is a 34 cage, it's missing 2 cells summing to 11. One of those digits cannot be a 1. Oh, no. Hang on. Stop brain. We know there's no 8. There's no 8 in the 34 cage. Because there must be an 8 in one of those squares. There must be an 8 in one of these squares. However these 8s are disposed in the finished grid, they're ruling out 8s. Because there are no... Well, yeah, the simple way of thinking about that is how many 8s are there in row 8 and 9 of this grid in the finished solution? Well, there'll be 1 8 in that row, 1 8 in that row. That's 2 8s. Well, there's 1 there, 2 there. So if we try and put another 8 into this cage, that will be 3 8s in the bottom 2 rows. That is nonsense. So there's no 3 or 8 in this cage. Because we know that because of the secret, the 2 digits missing must sum up to 11 to get us to 45. So there's no 3 and there's no 8. And 3 is an odd digit, so it can't go in a blue square, so 3 goes in one of those 2 squares. Which doesn't seem to do anything. We've got these squares as well to consider. These. Oh, lovely. Look at this one. This one, you can see from the colouring, contains 1 even and 1 odd. Therefore, it adds up to 11. And if that was an 8, that would be useful because that would be a 3, and then that would force a resolution of this 3 pair there. 8, 3, 3. Oh, right, okay. So this domino is the same, isn't it? Because a cage can't add up to 20, or 2, a 2-cell cage cannot add up to 2, this must also have 1 of each parity and be an 11 cage. So those squares add up to 22. So these 5 squares add up to 23. Oh bobbins, now it's getting very difficult, isn't it? Because I think I've looked at most things now. These cages all add up to 21. Small point, you can never put a 2 in a 21 cage. So there is no, so there is no 2 in the Fistum-Fell ring. So there is no 2 in the corner 2x2s. Right, okay, I mean, I'm not sure whether this matters, but that means the 2s have a funny pattern around the grid, look. Because in each of the corner boxes, the 2s have to go in a yellow square. And wherever, if we got 1, 2, it would sort of tell us the disposition of the 2s around the grid. Because if, for example, this was a 2, then you couldn't put a 2 in that domino, so it would have to go there, and then it would have to go there, and then it would have to go there. So the 2s are either in these dominoes here, or they're in those dominoes. I know, it doesn't do anything. I just noticed it, so I thought I'd say it. Okay, what on earth does that... Maybe I should label these up as not having 2s in them. But that will make me feel better and also look like I'm making progress, even if I'm not really. 4, 6, 8. There's always an 8. Yeah, okay, well let's now look at the odd digits in the 21 cages. That would be sensible, because we know that the 2 squares in all of these 21 cages that are not 8 have to add up to 13. So they can't have a 5 in them. You can't put a 5 as the odd digit, because then you'd need another 8. And you can't put a 1 or a 3 because you won't get to a high enough number. So that square, that square, that square, and that square all have to be 7 or 9, I think. I wonder if those 2 squares have to be the same digit. Is that something I'm meant to appreciate? So whatever goes here has to go in one of those 4 squares in the central box. I'm not sure actually. That doesn't look so promising. Okay. Oh dear. What is it? I'm not... Maybe I haven't really studied the 44 cage, have I? I know it's missing a 1. Yes. Yes. These 2 squares are odd. So that means in row 2, all of the even digits must be in these squares. Therefore, they are the 4 even digits that appear in a 44 cage are all in row 2. So this square cannot be an even digit. That's an odd digit. Now, that's obviously, I can label that up even. Let's just see if we can spot anything. What I'm looking for, of course, is any rows, columns or boxes that have 4 even digits in them, or 5 odd digits in them, because then you know they're complete. I'm seeing nothing. I can't see anything at the top of the grid. Maybe it's the... I was about to say maybe it's the 11 cages, but I feel like I looked at those recently. I'm going to look at the 34 cage again. The 34 cage we know is missing an 8, and we know is missing a 3. Oh, yes. Lovely. Absolutely lovely. This square is beautiful because this square sees the whole cage. This one. So this square cannot be a digit that appears in the 34 cage, because if it was, you couldn't put that digit in the 34 cage. So we know this square is a 3 or an 8, and it's not an 8. The 8 in that box must be in those squares. That's a 3. And that means what? That means that square is a 1 or a 5, because it can't be a 7 or a 9. Ah, this square here. I didn't actually notice. I got some 7, 9 pairs. That square can only be 1, 3, or 5 because it sees 7 and 9. And that's in the Fistomophel ring. So the Fistomophel ring... Oh, there's a 1, isn't there? There's a 1 in one of those 2 squares. So there has to be a 1 on the ring. That could be the 1. Oh, sorry. I think this is all... The 1 seems to be able to go in about 5... Well, at least 4 different places. 3... Oh, now that can't be 8. If that's 8, that's a 3 because this is an 11 cage. Oh, that's lovely. So that's not 8, which means this is 8, and I'm going to get all the 8s, am I? 8, 8, 8. Let's get rid of the 8s from the other cells. Now, does that... Oh, maybe it doesn't get me the ones in the middle. Oh, well, it still feels like progress to get 4 digits like that. So this is not 3, 8 anymore. Looks like we're going to be in for another long video. I'm not really sorry. I mean, the majority of the comments, actually, we were quite surprised the other day, said that people really like the long videos. So if puzzles do tend to take a long time, then we hope that you'll... Well, not only that you'll forgive us, but that you might actually enjoy that. Yeah, but I'm pretty sure people don't enjoy it when I just get absolutely stuck. Which is what seems to have happened now. Got 7s and 9s now, all are dotted around. Problem is that it'd be a bit nicer. Well, it's a bit maybe there 7, 9. 7, 9 is odd, so it's not possible for both 7 and 9. There must be at least one 7 or 9 to be in those 2 squares. Like, oh no, there could be 2 because the 1 could still be over here. Ah, right. What on earth am I meant to do now? I suppose I know that these squares, the ones that are not 8 in the corner cells, have to be from 4 and 6 because you can't put a 2 in them. Right, that's interesting. That is interesting. Or is it? I can see those 2 have to be different. Because if they're the same, you can't put that digit in that cage anymore. So whether this is 4 or whether it's 6, it's got to appear in the 34 cage, because the 34 cage is only missing 3 or 8. So those 2 are not the same. Ah, yeah, the other thing I'm noticing is that whatever goes in that square is not a 3 or an 8. So this square has to make an appearance in this cage as well. Well, where does it go? It can't go in the same box as itself. So whatever that square is has got to go there or there. And whichever one of these is not 8 has the same issue. That has to go there or there. So these wing cells of this 34 cage have to be either 1, 5 or 4, 6. So they are a little bit restricted. This is it's just brilliant. It really is brilliant setting. Now, let's come back to the thought we had earlier about these two squares. These two squares are different. So this square cannot be a 4 or a 6 because it sees both colours. If I coloured these, it would be clearer. I'm a bit loath to do that because then I'll lose the fact that these are both even. But we know these are not the same because that would rule the 4 or the 6, whatever it was, out of the 34 cage. So if these aren't the same, but both of them see that square, if you were to make this square a 4, for example, it would definitely rule a 4 out of one of those two squares, and that would break the puzzle. So this square is odd, and it's the same as that square, which I'm not going to have a way of... I could do multicolouring, I suppose. Shall I do multicolouring? Maybe I will. I'll use red. Red to indicate these have to be the same. And now this square, therefore, has to be whichever one of these is not 8. So this one is 4 or 6. Oh, good grief. Right, this is getting really complicated now because now that one is not the same as that one, but this one is the same as this one. Right, we're going to carry on colouring then. That can be purple, that can be purple. So one of these two is purple. This square is in an 11 cage as well, so this doesn't have that many options. That's got to be 5 or 7. So if this was 5, we would know what this was. Come on. Come on, Simon, think. So I'm not sure. Whatever this is has to appear in those squares, therefore, and therefore one of those two squares. Oh, I'm sorry about this. I'm getting very badly stuck. Oh, come on. Maybe it's not the 4s and 6s I'm meant to colour. I could try 7s and 9s. There aren't very many 7s and 9s. Maybe I could get what this is, though. That might be helpful. So whatever that one is the same as that one. Is that right? Yeah, that one, whatever. If this was a 9, it couldn't be a 9 in those two squares. Therefore, yeah, the 9s would be in those two squares. Hang on. 1 second. 1 second. Let me think. So these two squares are the same colour. So this... That's 1, 3 or 5. Because it sees 7 and 9. 1, 5, 7, 9. These squares have to go into the middle. These squares are the same. This square This square can't be 7 or 9. This is so... I mean, again, it's just another beautiful, beautiful piece of setting. It really is. If this square's 9, this square is 7, and this square is 9. Now this square now sees 7, because it's in its box with it, and 9 in the corner. Now the only other way of the world existing is like that. Whoops, like this. Which is the same point. This now sees 7 in the row and 9 in the box. So whichever way round these 7s and 9s are, it doesn't matter to us in terms of this square. This square cannot be 7 or... it can't be 3. 1 5 pair. Come on. 1 5 pair in the box. Because this 3 sees that square as well. So there's a 1 5... Oh, look at this. Now I get that square as a 3. Because the 1 and the 5 are in the box with this. And this could only be 1, 3 or 5. Oh. That's an amazing piece of setting, but it's not... no. I don't know if it's actually done anything to help me. What does 3 here tell me about the world? 3s and 8s seem so important in the puzzle with what was going on here as well. Here. 3 here is telling me that that can't be a 3, can it? Yes, okay. Maybe that's what it's telling me. This can't be a 3 because that would be an 8 and it would clash. So 3 in this box has to be in one of those 2 squares, which means 3 in that box has to be in one of those 2 squares, which... Nope, I'm not seeing what that does. Oh no, come on. I think I'm missing something very fundamental here, actually. I'm now sensing that I keep going over the same logic over and over again in my head, which is never a good sign. I didn't really get much use out of these, did I? I worked out those had to both add up to 12, I think. 24. These have to add up to 21. Oh, I see. Oh, God. Sorry, this has been here for a while. That's really clever. This square here can't be a 4. If that's a 4, how do we make these add up to 21 now? Well, there's only one way. That's going to have to be a 9. That's going to have to be an 8. But how do I make those add up to 21 as well? Because these are in a cage that adds to 21. Well, I'll have to put the 9 there. And now I've got a problem. 2 9s in column 3. Now let's just rewind this a little bit and instead do some... Oh no, I want those 3s up there. Let's try 6 here instead. If that's 6, how do I make these 3 add up to 21? Well, what I can't do is make this a 9 because that's going to need a 6 here. We know this is an 8. So we're going to have a 7 here. How am I going to make those 3 add up to 21? Yep, 7s, 7s. I'm going to get repeated 7s. So actually, this square here, once you work out that these are a 7, these are both 7 and 9, because this adds to 21 and this adds to 21, I mean, it's hard to see it. I only saw it the second time through. So I think that is hard to see. But it is also true. This square here just cannot be a 4 or 6, so it is an 8. And that is going to be absolutely beautiful, because that means this is not 8, which means we can place 8 there. This is not 8, so we can place 8 here. This is not 8, so we can place 8 here. And now, what's that done? It's done nothing. I can now make that purple, actually, because now whatever this is apparently here, and therefore has to go there. So those are purple. I'm just wondering if I can use... If we know that this... If we knew this was a 4, do we know how this ring goes round? If that's a 4, it forces this one to be 9, which forces that one to be 7, forces that one to be 6. So that's if that was 4. This was 9. That's therefore going to be 7. Sorry, so if that's 4, that's 6. Oh, but we would have known what this is, so that's affecting that. Right, so these alternate. Got it. Right, okay, let me just double check this though. I think that the 4s and 6 alternate round the ring. So if this is 6 now, we know that's 7. That forces this to be 9, which forces this to be 4. The 9 forces that to be 7. So we're going back into this one. That's 6. Not sure whether we... Do we know that one as well? I feel like I must know that this is 4 or 6, but I can't quite see how to do that immediately. I know that's 9. Don't know. But I think what it does mean is that we know that this and this are different. And if I know that's purple, okay. So if I know that's purple, this needs a new colour now. We'll make this one... Oh no, I can't use red. I used red for those two. What shall I use? I've not used green. I'll make that one green. And green is the same colour as this one. And we know that because we know that this one, whatever it is not purple. So we've got greens now. We know that green must appear in these 3 squares. Sorry. Do I know what that one is then? I don't think I do know what this one is. I know what that one is. I do know what that one is. That one is definitely purple. Because it's not green, because of the effect of this one on that one. Purple is now on the... Oh, I know what that one is. Because purple is not in those 3 squares, therefore purple is somewhere there. Therefore, purple is somewhere here. Therefore, purple is not that one. So that one must be green. Oh, this is just gorgeous. Now, look at green. Where does green go in column 8? I've got green here. I've got green here. Well, purple is not green. So green goes there. And therefore, that square is a 4 or a 6. Therefore, this square is a 5 or a 7. And now we've got a 5, 7, 4, 6 quadruple in column 8 of the grid. And this must be important. It's too beautiful not to be important. Green is not purple, so there's a green in one of those. Yes, it's the same. This green here is in one of these 3 squares. So it's in one of those 2 squares, but there's a green here. That square is green, and therefore is 4 or 6. Therefore, this square is green. Oh, so it did alternate. There's probably another way of me proving that. I just didn't see what it was, sorry. Now, green is in one of those 2 squares. Purple is in one of those 2 squares. No. Also, these are the same colour now, because if we look at what we've got going around the wings of this 45 cage, I've got a 135 pair, triple I should say, and this one, which is a 7 or a 9. Now we know those 3 squares there have to appear in these 4 squares, so they must go into those 3 positions, because this one has to be a 7 or a 9, presumably because that's in the 21 cage. I can't remember why I pencil marked that, but that seems to be logical. So this is a 135 triple. These 2 squares are the same. I'll try and notate that so that I remember that. I will use dark grey. That's the other thing I've got to remember, you know, is that some of these... This square was an even digit, wasn't it? That's why it's sludge coloured now and not beautiful blue. So that square's 2, 4 or 6. Which unfortunately... Oh, if it was 4 or 6 that would be interesting, because then it would have to be green as well as being sludge. Oh goodness me, this is going to be way over an hour again. But it's been absolutely magnificent, I will say that. I have loved this. I just wish I was a little bit cleverer and I could get these done for you a bit more quickly. So what do we do now? What do I do now? I've done... Now if this was a 1, that would have to be the 1. Maybe I've got to use these. This quadruple, I've not really thought about that. Or maybe it's... I need 1, 2, 3 and 9. I've already... These squares are 1, 2 and 9 in some order. Sorry, I'm not spotting it. What is it I'm meant to look at here? Those and those are the same. Hang on a moment. Yes, got it. Right, now, that can't be a 6, because it's green. I know that sounds illogical, but it's true. If this is 6, we know that's 6 as well. So these 2 squares are 6. But the problem with that is that this square is a 7 now, by maths, because this adds up to 21. But also, Because if this is a 6, look, that has to be a 4, that has to be a 7. You get repeated 7s in box 9. That will not work. So this cannot be a 6 and must be a 4, and therefore 4 is green. And we can place lots of 4s in the grid. Happy days. That's a 6. That's a 6. That's a 6. That's a 6. That's a 6 as well, actually, because it's not a 4. So that also is purple a bit. So now this square is not a 6. I'm not sure if I know whether that's green or not. But I must now be able to do some more stuff. That square is a 7 because we know that's an 11 cage. This is a 5. Oh, look, this 5 gives us that that square is a 1. Therefore, from red, that square is a 1. Therefore, there's a 1 in one of those two cells. Now, has this... Yeah, now I can start doing maths again. That's a 7. That's a 9 in order to make that add up. We know that's the same colour as that. That should be a 9 as well, therefore. This is a 7. This is a 9. Good Lord. This is one of the best puzzles I've ever seen. I will say that. That's a 5. And that is because not only is it just incredibly... It's an incredible solve. But to do this and execute this so beautifully with this rule set is just... It's a joy. Now, do I know what that is? I feel like I do, but I feel like I should do. Let me temper that. I should do, but I don't. Now, come on. What have we just... I feel like that should have just broken the back of the puzzle, but I'm still not sure that it has. I can now see there's a 4 in one of those two cells. I can see there's a 6 in one of these two cells. No. Okay, maybe I've just got to study some of these rows and columns harder now. So that square's a naked single. It can't be 5 or 6. That's just a 2. Wow. Okay. So this is a 5-6 pair and there's a 6 there. So that's a 6 and that's a 5. Did not expect that. This 5 needs to be odd. So let's put it orange. The 6, I don't know if I need to have the 6s coloured anymore. I'm tempted to try and get rid of some of this colouring because it's very distracting. Now those squares have got to be they've got to have a 7 in them somewhere. We know the order. That's 7. That's 3. Now I've got a 1-3 pair here, look. And I've got a 7 into one of those squares in my 34 cage. And those two squares now have got to be 2 and 5, which I don't seem to know the order of. But that means I actually do know this digit is a 9, apparently. Because it seems to have to be a 9 to complete the box. So that's a 9. Which means that 9 is now appearing in one of those two squares in box 1. These squares are a 2-7 pair, which I don't seem to know the order of, but I shall certainly put them in. I'm going to get rid of that 34 cage marking now because that's going to confuse me as well. I'm going to put 4, 5. Oh, I almost made a mistake there. I put 4, 5 and 7. I was like, I've got a 7 in the row, but no, it's 4, 5 and 9, I think, and that looks better. So there's no 9 here. feel like I must be able to disambiguate the 1s, 3s and 5s in the middle box, but I don't see how to do that instantly. Okay. So, where does that leave us? Now that can't be 9 because of the 9 here. I think I might have to get rid of the colouring. I'm loath to do it, but I almost want to... I've got a 1-3 pair in this column, look. 2 and 5 have not been... Yes, 2 and 5 haven't been placed. That's a 5, naked single. 5 and 2 go in. This square's a 4. That's not 4 anymore. And it's not 5 either. That's a 9. Lovely. So in this column, maybe this column is where we're meant to look next. We need 2, 6 and 7. So that, maybe we're not. Okay, let's put all the options in and see what we can rule out. We can rule out 6 from that one. We can rule out 7 from that one. I don't know what we can rule out from this one. 2, 6 and 7. Okay. So now what do we do next? We must do something else. How many 6s have I got in this? Oh, see, I can't even see when I double click where all the 6s are. I've got to put... I think there's a 6 over here. 1s and 3s, is it? This 2 is in the same cage as that one. Let's get rid of that 7. Now I've got a 2-6 pair in here, so I must have almost finished my my 45 cage. Look, I still have not put into it a 7, I think. I think I need a 4 and a 7 into those squares. Might be wrong about that, but... 7 is now in one of those 2 squares, which means it's in a... We know which... yeah, hang on. So we now know the composition of this cage, because it's got a 7 in it, and it adds up to 12, and it doesn't include a 4. So this is 2, 3, 7, which is... Yes, that is useful. That is very useful, because there's a 3 here and a 7 here. So the 3 and the 7 go in the top of the box, and that makes that square a 2. Which means that is not a 2. These are not got 2 in them anymore. We must be able to deduce what these are. They must be 1, 5 and 6. And we have a 6. That's lovely. We get a 6 here. That fixes the 6 and the 2. We've now got a 1, 3, 5 triple, so we need to place a 9 in the row. We can do that. Now, it looks like I've got a 3, 9 pair in box 3. Those squares, we still don't know. It's a 1, 2 pair. Yes, we do. There's a 2 there. So that's a 2, that's a 1. And that, after all this time, I've now found where the 1 went in row 2 of the grid. So 1, 2, 3, 4. These squares are 5 and 6. I can do that. That's a 6. That's a 5. So this is not... Oh, this isn't 3 or 5 because of the 3 here. This is 1. This is 2. This is 1. This is terrifying as well. What would happen if I made a mistake now? I would probably cry on camera. That's a 5. That gets you a 5 and a 2. Don't be mean. You don't want to see that. Now... 7. 7's here. That's a 7 by Sudoku of all things. That gives us a 9 here. No, a 9 here. Don't be naughty. 3 here. That gets us the 3 and the 1. That means this should be a 1. This is a 9. This is a 3. Come on. Keep going, Simon. 1, 2. I need 3 and 9 into the middle box. I can do that. 9 and 3 go in. There is no 1 in this cage, so that looks good. The 3 and the 5 can go in at last. The 5 and the 4 can go in. That gives us the 4 and the 7. The 7 and the 2. The 2 goes here. I need a 1. This square should be a 3. And I think I finished it. I think. I'm going to click tick. Yes, I did. I am so pleased with that. That is really amazing. It's an amazing puzzle. Absolutely amazing, and I loved it. Mr. Menace, take a bow. That is one of the great Sudokus. Let me know in the comments how you got on with it, what I missed in it. Maybe I did well today. That was not easy, I don't think. And yeah, maybe worth a subscription if you enjoyed it. So yeah, please subscribe to the channel, and thank you so much for watching. And we'll be back later with another edition of Cracking the Cryptic.